Solid-state batteries. It sounds like something only engineers talk about. But this technology might be the most important breakthrough in energy since the invention of the lithium-ion battery. And if it works the way scientists and companies say it will, it could completely change the way we build electric cars, store renewable energy, and power the world. Today, almost every battery around us, in phones, laptops, and EVs, is based on lithium-ion chemistry. These batteries have served us well for the past 30 years. But they also have serious limitations. They degrade over time. They can catch fire. And they just aren't good enough if we want truly fast charging, ultra-long range, and full safety. So what's the problem? Current batteries use a liquid electrolyte. That's the part that allows ions to move between the positive and negative sides of the battery. But that liquid is flammable. It heats up. It leaks. It limits how much energy you can pack into a battery. And it's one of the reasons why your phone battery slowly dies after a few years of use. Solid-state batteries change all of that. Instead of liquid, they use a solid material, usually ceramic, glass, or a polymer, to carry the charge. This solid electrolyte doesn't catch fire. It doesn't leak. It can handle high temperatures. And most importantly, it allows for much denser and more powerful battery designs. What does that mean in real life? It means electric cars that can go more than 600 miles on a single charge. It means charging those cars in just 10 minutes. It means a battery that still works like new after hundreds of thousands of miles. No overheating, no fires, no loss of range, no more waiting hours at a charging station. Toyota announced in 2023 that it had successfully developed a prototype solid-state battery with over 750 miles of range and charging time under 10 minutes. QuantumScape, a US startup backed by Volkswagen, is working on its own version, and early tests show that it can survive over 800 charging cycles with barely any degradation. That's the equivalent of driving over 500,000 miles without losing range. And they're not alone. Companies like Samsung, Ford, BMW, Hyundai, and even NASA are investing heavily in solid-state battery research. Everyone wants to be first. But this isn't just about EVs. Because of their safety, energy density, and long lifespan, solid-state batteries could transform more than just cars. They could change how we store energy from solar panels and wind farms. They could power drones, spacecraft, airplanes, and even medical implants. Imagine a smartwatch that never needs to be charged, or a pacemaker that runs for decades without a single battery replacement. And for countries trying to reduce carbon emissions, solid-state batteries could be the missing piece. One of the biggest problems with renewables like solar and wind is storage. The sun doesn't always shine. The wind doesn't always blow. But solid-state batteries could act as huge, stable energy banks, balancing the grid and keeping homes powered all day and night. So why don't we have them yet? Because building them is hard. Really hard. The materials must be extremely pure. The manufacturing process has to be incredibly precise. One tiny defect and the whole battery might fail. And then there's the cost. Right now, solid-state batteries are still far more expensive to produce than standard lithium-ion cells. But that's starting to change. Governments and corporations are pouring billions of dollars into research. New pilot factories are being built in the US, Japan, South Korea, and Europe. The US Department of Energy has listed solid-state battery development as a national priority. Automakers expect to release the first production models with solid-state batteries between 2027 and 2030. And many experts believe mass adoption could follow within the next 10 years. There's also a sustainability angle. Solid-state batteries may require fewer rare and controversial materials like cobalt. Cobalt mining, especially in parts of Africa, has been linked to child labor and environmental destruction. If solid-state batteries reduce the need for cobalt or eliminate it completely, the environmental and ethical impact of EVs could be drastically improved. Recycling is also easier. Because these batteries have fewer toxic components, they're easier to process and reuse. And since they degrade much slower, there will be fewer dead batteries ending up in landfills. This kind of progress could also mean greater energy independence. Countries wouldn't have to rely on oil imports or unstable lithium supply chains. They could store their own power, made from the sun or the wind, and use it day and night without interruptions. But there's also a geopolitical side. Whoever perfects and scales solid-state batteries first could dominate the next generation of energy and transportation. Just like the countries that led in oil and gas shaped the 20th century, those that lead in battery technology could shape the 21st. That's why China, the US, Japan, and Europe are now in a silent race. Behind the scenes, they're building factories, filing patents, and fighting for raw materials. Because once this technology goes mainstream, the global economy could shift. And it's not just governments and automakers watching. Investors, tech giants, and energy companies are all lining up. Billions of dollars are being poured into startups, labs, and pilot projects. If even a few of them succeed, the payoff could be massive. But we should stay realistic. Like any new technology, solid-state batteries come with challenges. They won't magically appear overnight. There will be failures. There will be delays. Some prototypes might never make it out of the lab, and scaling production to meet global demand will take time. Still, the direction is clear. The way we power the world is changing. Fossil fuels are slowly losing ground. Lithium-ion batteries helped open the door, but solid-state batteries could kick it wide open. They promise to make energy storage safer, cheaper, and more efficient. And they could make electric transportation faster, cleaner, and more accessible than ever before. It might not be this year or next year, but by the end of this decade, everything could be different. A battery that's safer, lasts longer, charges faster, and holds more energy? That's not just a nice upgrade. That's a revolution, and it's already started. Subscribe us for more videos.